Hey everybody, and welcome back to ModiMate's step-by-step tutorial series, where we are taking a project from its first strokes through to a completed state where it produces instant DWGs, renderings, and quantity estimates. In the last video, I said we would be working on ceilings. In this video, I lied again. We're going to be working on eaves. They're a common extended topic based on roofs, and we just covered roofs, so we're going to cover some eaves. Now, there are two major categories of eaves design. For those who aren't aware, eaves are the overhangs outside of a roof. And some people like to design them as a known dimension in the plane of the roof so that they can be extended rafters of the roof. Other people like to design them in silhouette plan design so that they can relate to other types of projections off the walls of the building. In our case, we're dealing with one added variable, which is that our roof slopes are hybridized. We have 8 to 12 slopes and we have 4 to 12 slopes in the same roof design. It happens to just work nicely for the massing and space of our building. As a result, we are going to, the problem with hybrid roof slopes is that if you have a constant overhang distance, a steeper slope is going to make the roof line hang lower. If you went out 2 feet from here and from here, you would only descend from a 4 to 12 ratio 8 inches on this side, whereas you would descend 16 inches on this side. So instead, we're going to actually have a design where the overhangs are different depths off the building's face, but have the same total descent in Z height. The eaves will descend 6 inches, and on this side and the opposite, they will be 9 inches deep, whereas on the front and back, they will be 18 inches deep. All right, let's get started. Really quickly, if you did want to design with respect to the axis of the rafters, all you have to do is click along the rafter edge of any major gable if you have one, or you can just come down and measure something similar on the face of a hipped face. You can come down here and find a corresponding point, connect these two, and you've got yourself a construction line to start working in the same axis as the line that you just drew. As we covered in the last video, clicking on 2 points in a row along an edge that are not aligned to any world axis will start to give you extra affordances to keep you aligned to those special edges. That's how construction lines can be used to create new surfaces. But I don't think we're going to work that way for this design. Instead, we are going to work in plan silhouette design. So we know that we want our eaves to drop a total of 6 inches, and this slope is 8 to 12, which means that we're going to want to go out 9 inches and then descend 6 inches, and that is the size of the eave for this side of the building. It's pretty small, simple eaves, but it's also a pretty small project, so it seems to fit nicely. So if we are going to, the next thing we can do is use a rectangle tool and extrude that sloped edge as we did for the roofs. We're going to come over here. We have a similar small eave coming down here of 9 inches across, 6 inches down, and then extend this rectangle along to this point. I was holding shift there to make sure that the rectangle stayed snapped to green. And that completes those two sides. Lastly, I'll do the same thing here. And I can demonstrate a new tool really quickly. I'm going to copy this triangle over to this eave. And the way I do so is by using the move tool, starting a move vector from a point, which doesn't work in this case because that triangle can't move anywhere without deforming one of its neighbors. This plane is pretty rigidly locked. If it tried to move this way, it would warp the wall below. If it tried to move upward, it would warp the roof plane. It can't really move anywhere. By comparison, I believe this line is going to be flexibly able to move up and down because its neighbors can be warped without turning non-planar. But I digress. Let's go back to the copy command. It's actually built into the move tool. You start a move, and then you press the control key, and you can toggle between a move and a copy. This is we've actually borrowed this command from other similar software. And the reason that we think it's successful is that copying is most successful when you have a precise starting point and a precise ending point that relates the original from the copy, same way that a move tool does. So in this case, that was what we needed to get the exact same shape over here. If I did so much talking that it ended up quite slow, but if you copy, you can typically save quite a few clicks over redrawing content. All right, so this edge is now in plane with the rest of the roof. We will take it across the building over here. We now have all three of the eaves that match up with our 8 to 12 slopes. And then we have two edges that are 4 to 12 slopes. Let's give those ones a go. We have 18 inches by 6 inches. All right, and if we take this edge and extrude it across the face here, there's one. Now I can't copy that triangle over here because they are opposite orientations, and we are still working on our mirror tool as of May 2021. I'll go 18 inches out, 6 inches down. There's a lot of triangles in roof design, but at least we're not dealing with sines and cosines and tangents. It's not real trigonometry, so that's great. In this case, as we extruded the front eaves over the garage towards the main foyer, we saw that the two planes intersected, and the slope intersection happens, of course, to be identical to the primary valley of the roof. And because we designed these two eaves to both be the same descent, their bottom points line up nicely. We have some extra roof geometry here, which if I delete is going to clean up nicely. Extra geometry here. And then, of course, there's the construction triangles that I used at the front. Lastly, we will complete these shapes, which, again, because we planned the low points to be the same elevation, is going to be a nice, easy triangle project. Just connect 3 edges there and delete the unnecessary edges. We've got ourselves a nice eave. Connect those points and the ridge. Delete our construction elements. And then we will do the same thing in the final corner. We will delete our construction elements. We've got ourselves eaves that are a little bit unusual in terms of their differing depths off of the steep and shallow slopes, but they are going to be nice and easy to build because they have a continuous height, and they look nice and clean as a result. I think as just an arbitrary addition, I'm going to also extend some eaves over the top of this gable. I will extend this plane out by, let's call it 9 inches, just to match the rest of the shapes on this side of the building. Could go a little further perhaps, but I'll stick with 9. And I'm extending rectangles and just clicking here and then snapping to the point that guarantees me the right shape. So I don't have to think too hard about holding shift. It's just mouse on over, snap and click. All right, so if we delete these construction lines here, we now have ourselves a whole rafter system, an eaves system around the whole building. Very simple roof design, but that makes for a successful rain and snow shedding strategy here. Although there probably won't be a lot of snow given this roof slope, but here we are. Okay, in the next design, we really will get inside the building and start working on some ceilings. Catch you there.